All right. Before we kill Matthias, let's get started here.
Like simulate dying.
Yeah. Trick me into thinking.
And also the thing with my orientation degrees, because his skin is so cold, but he wouldn't actually be. Yeah.
And I mean, you could reach 420 degrees.
I'm pretty sure he would die long before reaching 420 degrees.
Not if you found a way to somehow instantly heat it to 420 degrees, you would die at the exact moment.
That's true.
I think
Fly
the
him
solution
into
to
the
that
sun.
problem is easier.
But that's all I have to say. Can I borrow a pencil?
All right. Without killing him, though.
If you kill me, I can't kill you.
I'm sorry.
All right, let's go to 4.3. Let's see. I think I said I was going to do like a calculator section or day with you guys, right? So maybe we could do that. I'm thinking maybe like next Friday-ish, maybe something like that. That'd be good.
That would be.
And it's you guys come with.
That'd be amazing.
Yeah, you guys come with any calculator questions you guys have. I'll have a little set of what I want to do, then we'll kind of just work together. So bring your calculator next Friday. How about that? All right, let's go get started. 4.3 is where we're at. We are putting the last few touches. So let's see. 4.1 was the intro to all this good stuff. 4.2 was just sine and cosine, and we started manipulating things, right? We manipulated the vertical stuff. We started stretching it vertically, right? Or making it shrink vertically, right? And then the other one was, making it expand horizontally or shrink horizontally, right? Those are the two. And then, what's the other one? There was one more. Anybody remember one more that we did? It was only like 2 days ago.
Was it the reflection?
Oh, reflection, that's right. So you can reflect it about like this. So that was cool. So these three things here. Okay, two more. So a total of 5. So vertical translations, maybe let's do this here first. I'm going to give you the big different, the big equation to this stuff. So I could either write it as y, because it's just a graph. I could say it's f of x, because it's a function. So either one of those are just the same, okay? But here's what we're going to do. We're going to put a over here. This is the way the book does it. And we have sine of, and then we have b, which is multiplying x minus h. Oh man, this is huge stuff. Plus k. And I don't know why the book does it. The book kind of writes the k in front sometimes, or at least a good portion of the time. I have no clue. Usually we like to see the vertical face up at the end. Okay, and then let's do cosine as well here. So y is equal to f of x is equal to a cosine b. So based upon what the capital A, capital B, little h, little k are, we can graph these. So let's go with it here. So a few things here. If you say amplitude, I guess I should spell it out here. Amplitude is going to be that a value in its absolute form. There's your amplitude. It means how high it goes from the middle to the top. And then we have, particularly for sine and cosine, our period value, as we did last time, it's going to be 2 pi divided by b. We just take the b value, divide it, and then we know exactly how far we are stretching to give one full period. Okay, and then we have something called the phase shift. Now notice the b value is actually multiplying in times x times minus h, right? We have that little, okay, phase shift. And next to it, you probably just want to put this here, horizontal shift. Phase shift is the horizontal shift. Now this one is not stretching horizontally, it's just individual dots being placed a little bit over to the right or a little bit over to the left, and that guy is h. All right. Notice also that h in the equation is negative, but then the phase shift is positive, so it goes the opposite direction. We good? All right, and last one, vertical shift. Vertical shift is k. All right, that is it. That's what we have. Jamming with this here. 1, 2, 3. I do want to say 1, 2. There's in trigonometry, there's actually 3 different ways to do this. This is the way your book does it, so I'm going to stick to your book in case you want to read up on it, so then you're not totally confused. Mr. and G have said it this way, but we're doing it this way, so I'm lost. Okay, let's go back to algebra 2, just real quick here. Don't need to write it down, kind of think with me. So do you guys remember in algebra 2, graphing x squared? I think we should. I think so. Hopefully. Did you ever guys graph x squared in algebra 2? Okay. So x squared, I think, is a parabola, is right? It starts off at 0, 0 as the vertex, goes off to the right like this, goes off to the left, and voila, we have something looks like this. Good there. So then if I were to graph x squared minus 3, notice the minus 3 is not inside with the square, it's totally on the outside. It's kind of like the k value. And talk to me, anybody, what does the minus 3 do to this graph? Guesses are welcomed.
It either shifts it horizontally or vertically, but I can't remember which one.
Okay, sounds good. And so if you think about whatever you do to x squared, at the end of the day, you're going to just subtract 3 from it. So in my mind, that means that's x squared. At the end of the day, that little 0, 0 is just going to have to come down to here, right? And then that little 1, 1, that comes down 3 units. That little 2, 4 comes down 3 units. So x squared minus 3, it's a vertical shift. Are we good? That little guy at the end. So it's technically our k value. If k is positive, it goes up. If k is negative, it goes down. That's what we have in our hands here. So I think we're good to go. So from what we learned from 4.2, let's see if we can do this here again. X squared plus 1. You should know where that's going to go. 5, 4, 3, 2, 1. There it is. There's my vertex. And then we go up from there. Everybody good? Love it. Jam it. Let's go. So exercise 1. Can you graph for me? Y is equal to, and I'll just, I guess I can use interchangeably y or f of x. It doesn't matter. Any of those were just fine. Let's do an easy one. And so we'll do it the faster way. Now that you guys have your homework done for 4.2, you've tried it. That was totally sarcastic. And so what we generally do is this. We take a look at, besides the vertical shift and the phase shift, we want to be able to graph 3 sine x all at once. We're good? And so we make our little graph. And we know I'm going to write it down here because I know I'm going to move up 2. We're good? So off to the side, we look for our amplitude, which is 3. We look for our period. And we look for any reflections here. So based upon my amplitude and my period, technically I'm just graphing this little piece right here. Period is going to be, everybody okay with 2 pi? It's 2 pi divided by 1, right? 2 pi. So in this case, I have a sine curve going up to 3, going down to -3, and sine curve in your mind, right, goes like this, starts off at 0, 0. Well, not in your mind. I'm not sure what's happening in your mind, but it should go like this. Here's my little important dots right there, right? Starts off at 0, 0, goes up, comes down, back to 0. So I'm going to label this 1, 2, 3, 4, 5, 6. 1, 2, 3. So my initial dots are here. This is 2 pi. That's pi. That's pi divided by 2. That's 3 pi divided by 2. So initial dots, are we ready? So 0, 0, still starting. Well, by the time we get to pi over 2, we're up to 3. At pi, we're at 0. At 3 pi over 2, we're -3, and we're back to 0. I'm not going to connect those points at all. Those are just initial points just for me to have a reference. All right, and what am I going to do to these guys?
Shift them all up to.
Perfect. Yep. Now I'm going to add in my vertical shift or my phase shift, any which way I need to do. That is going to be now up 2 units here. This guy goes up 2 units as well. Up 2 units. Up 2 up to perfecto. There it is. So I'm going to graph my sine curve. A little too fast. Okay, make sure that it's not a V shape, right? Make sure it's a nice curve. It curves out to those points and then curves back out. Okay. Not very super nice, but it's close enough. Cool. All right. Should we, let's do one more just to see how it works. Maybe two. We'll see. Okay, talk to me. Are we done? Pretty easy. Looking a little easy here. All right. Graph for me this. And I'm actually going to say I need a graph from 0. So here's where I'm actually putting in your domain restriction now. And then the question comes up, Mr. NGO, how did you know that you needed to go on the positive scale? You need to go up to, was it 3, right? Or 6, right? But on the bottom, you only went up to negative, down to -2. So now let's talk about that. What's the final graph going to look like? So before we begin here, how about a maximum value we need for a y value and a minimum value eventually? So let's talk about this guy here. Let's see. Cosine. You guys remember that cosine, what's the maximum cosine can be? 1, huh? Yeah, minimum cosine can be? -1. Okay, so let's do this here. Let's, in our minds, just real quick here, plug in a -1, or sorry, a +1 into here. And you guys tell me what the value is there. Let's see, that's gonna be -2, -3, -2, -5. Right? So I got a -5 on my hands here. Then I'm gonna plug in a -1. And answer here is I would think just -1, right? So there it is. Okay, so I have a minimum for this graph is -5, maximum is -1. Are we good? So at least I know my y values where they should be at the end. Okay, I think I'm good there. So figure out my max min. Let's see what else. We need amplitude. Everybody okay with 2 here? Sure. Amplitude is the number in front of your trig function here, and just take the absolute value of it. And then amplitude and period are the ones that come in first, because we want to graph that particular one all at one shot. Period is 2 pi divided by 1 still, right? Because it's a little 1 right here that's multiplying the x. Okay, so real quick here, can we do this at least? Can we graph the cosine function? Oh, that's right. And we look for any reflections as well. Just real quick here, do we have a reflection? Yes or no? Anybody tell me, how do we know reflections? I don't know. It's Friday. I don't know, sure.
It has something to do with the even and odd, right?
Ooh,
Or is it
no.
just the negative?
It's just the negative
Okay, well, then
outside,
if
so
there is a negative, so would it be flipped?
So
Is the negative in front of the cosine?
perfect. Yeah, it's because this little 2 is a -2. So do we have a reflection? Absolutely. We have a reflection in our hands. And it's always the reflection against the x-axis. Okay, so now real quickly, here's what we want to do. We want to be able to graph a cosine function that goes up to 2, down to -2, has a period of 2 pi, and has a reflection about the x-axis. Can we do that all at once? And then we also need to, by the time we end, our graph paper has to have some room to give us a, going from -5 to -1 along the y-axis. Okay, talk to me here. Am I going too fast for you guys? Or is it okay? Okay, okay. So y-axis, eventually we're going to end, our graph is going to be between -1 and -5. Initially, just to get our points, we need to have a +2 here. So I'm going to go a little bit higher. So I'm going to go 1, 1, 2, 3, and then 1, 2, 3, 4, 5, 6. Are we good? Our period is 2 pi. So that's pi over 2, and 3 pi over 2. All right, talk to me. When are we out of here? 9:45? Okay, let's see if we can get to the second part. Okay, first part, can we graph this guy? Cosine curve, amplitude is 2, period is 2 pi, and we have a reflection. So in our minds, remember cosine goes like this, starts off with a high value, hits the 0, goes low, up through 0, gets back to the high value. So initial dots. Oh, that's right. And we have a reflection. Oh boy. So in our minds, real quickly here. So this time it's going to be low point, 0, high point, and then back to low point. We good because of the reflection. And so our spread is between -2 and +2. I think we're good with our initial dots here. So initial dot is at 0, -2. Pi over 2, 0. Up to 2 at pi, back down to 0, 3 pi over 2, and back to -2 at 2 pi. We good? So we handle these three things first: amplitude, period, and any reflections if we have them. After that, then we do this guy. So let's take this guy down by 3 units, and I think we should be done. 1, 2, 3 is right here. 1, 2, 3. 1, 2, 3 gets us right here at -1. 1, 2, 3 gets you down to -3. 1. All right, if I can count, math teacher can't count. Am I going to go 1, 2? It should be down here. Is that right? And 1, 2. Yeah. There. 1, 2, 3. 1, 2, 3 should be right here. 1, 2, 3 now is right here. 1, 2, 3. 1, 2, 3. Are we good there? All right, on the test, sometimes I'll leave this as blank so you can fill in your scales for the y-axis and x-axis. Sometimes I'll actually put in the scale for you. We good? So kind of be mindful, you're gonna have to figure out how to do it both ways, just to make it more difficult for Matthias. That's pretty much the predominant reason why. Okay, are we good with that? Okay, so let's start changing up just a little bit here. Let's do All right, and also looking at the time, we might not get to the other one here. So let me see. Let me think of something from the top of my head here. 3 cosine of 2x plus 1. I think that'd be good enough. All right, and I do want you to graph it from 0 to 2 pi. I want to see that graph. All right, and let me get up. Just going to walk around to see how you guys are doing. That's all. Just going to give you a sense of things. And ask me questions if you need it, right? This is you trying it yourself. See if you can do it. So think of how much it's going to take to do one period first. Difficult or no? Maybe it's slightly more difficult. And talk to me if we if you're totally stuck, just wait just a little bit, we'll do it together. That's no problem.
So for the minimum and maximum, when there's a 2x inside, would you just multiply it by the 2 and then split out?
Oh, perfect. No, because the cosine value itself, cosine of 2x, that whole thing is going to be biggest number is 1, the lowest number is negative. So that 2 does not affect the amplitude, the height. So let me see if I can do this. And they're waiting for me to do it. Let's put together. So I may ask the question here. Does the 2 affect how big it goes or how low it goes? It does not. So this whole piece here, the highest it can go is 1, the lowest it can go is -1. And so off to the side, highest it can go is 1. So let's see, that's going to be 4. Is that right? The lowest it can go is -1. And that's going to be a, what, -2, I think? Talk to me, is that right?
Yeah.
Yeah, -2. Okay, so notice I don't do it first, because notice on the last problem, when I plugged in a positive one, that gave us the minimum value, right? Because I had that little -2 to multiply with, right? So my maximum for my graph would have to be a 4. My minimum is going to be a -2. I got that taken care of. Next is amplitude is 3. It's just the absolute value of that guy right over there. My period is going to be 2 pi divided by this little 2 right here. Now my period is just pi. And any reflection.
No.
And that's a no. Okay, so in my mind, I'm looking at a cosine curve. So that's going to be cosine curve. Starts high, hits the 0, goes down to the negative, goes back up to the high value. Okay, so I am looking for 2 things here. I'm looking for initially to be able to go 3 and -3 along my cosine value. At the end, I want to be able to stretch it out to 4 and -2. That's pretty much it. So at this point, I think I'm just going to go up to 5 and be done. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 would be good enough for me. That gets me both graphs in there. If you want to go up to 4 and -4, that's fine too. Okay, but I do have a specific domain I need to be doing. So I need to go all the way out to pi over, or 2 pi. So I do this now, that's pi over 2, that's 3 pi over 2 initially. But then my period is only pi. So what I have to do is I have to break up this little piece right here into 4 sections. So how about this guy being still cut into, sorry, not 3 pi over 4, thinking ahead. Half of pi over 2 is going to be a pi over 4. You just multiply the denominator by 2. And then you can start counting. So pi over 2, pi over 4, 2 pi over 4, 3 pi over 4. But we're going to have to do the same thing on the other one too, right? So I'm thinking to myself, hold on, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4 is pi. So this will have to be a 5 pi over 4. This is 6 pi over 4. That's 7 pi over 4, and that's definitely 8 pi over 4. Ooh, are we good there? Okay, initial dots, let's go. So here's my initial graph right here. So up to 3, 0, 3. Pi over 4, down to -3. Up to 0, up to +3, go to 0, -3, 0, +3. Boom. Not bad. Let me change pin color. And I think you guys know what to do with the rest of it here. That little +1. All right, that little +1 just means I'm going to move all these dots just 1 up each time. Oh, my little zeros here. Got my zeros. That 0 gets moved up. That point gets moved up, and moved up. And I think I'm done. Here it is, cosine curve. Coming down, coming back up, coming back up, done. Fun little W. I think we can probably do that. Let's see. Okay. Let's get into talk to me. We're done. Anybody need more time? Anybody need more time? Going once, going twice? How was that? Like great, thumbs up, it was great. Middle term, I struggled through it, or like Mr. Henry, I still have no clue what you're doing.
Basically, this section was just like moving it up and down.
This one's gonna be moving up and down, and also horizontally as we get to it. Okay, cool. Okay, one more. Let's see. I think if you guys can do this by yourself. Y is equal to, let's see, 3 minus 2 cosine of let's go to 5 just to make it fun. 5. All right, so we're not going to finish 4.2 today. A few more things left to do here, so we'll do this on Monday. But to see if you guys can do this one by yourself. All right, let's go with it here. One, one. All right. Doing this silently, see if you guys agree here with mine. I have a reflection on my hand, so it's gonna be cosine, so it's gonna be flipped. I need to go all the way up to 5 and down to 1 at the end. And I need to go to up to 2 and down to -2 initially when I graph this guy. So thinking, my graph, you may disagree with me here. My graph is gonna go from -2 to 5, or maybe 6. Let's see, 1, 2, 3, 4, 5, 6. Maybe like 1, 2, 3. I guess I'll go down to 3 just so I have a little shape graph here. Okay, in this case, we're going to go out to 5. So 1, 2, 3, 4, 5. So this one, as we said on Wednesday, this is maybe you're modeling something that takes 5 seconds to cycle through, or 5 days to cycle through, right? That's, or 4, sorry. Period is 2 here, so it takes 2 seconds to cycle through, or 2 days to cycle something. And we'll get into some applications on Monday. That'd be fun to see, like, oh wow, this is actually used in real life. Okay, let's go with it. So we're gonna go down, start low, go up, and then go back down, and we have to do it in 2 units. Oh, that's no fun. Hold on, my scale is a little bit off because I have to still divide this into, I think I can manage. Let's see. So if this is 5, 4, 3, 2, 1, so 1/2, 3 halves, would that work? Or 1.5, we could do 1.5 here. So I need to do everything from 0 to 2. Are we good? So I start off at -2, go up to 1/2, +2, back down to 0, down to -2. So I have to put these little markers in here too. So boom, boom, boom. All right, so then I go back up to 0, up to 2, down to 0, down to -2, 0, and eventually up to +2. Are we good there with those dots? Okay, and we are going to move this guy up 3 units. And we are almost out of time, so I better do this quick. 1, 2, 3. 1, 2, 3. 1, 2, 3. Did I mess up? Seriously? Am I going fast? No, I didn't. It's right here. 1, 2, 3 goes here. 2, 3. 1, 2, 3. 3. 1, 2, 3. Okay, talk to me here. Do you guys have something looks similar to what mine is? And it should end high, right? So you should have 2.5 cycles in this process. Okay. All right, we just did the first part only. We're going to continue on Monday to finish off phase shift and then actually start some applications. Like, where do we use this stuff? What do we model with this stuff? Besides that, have a good weekend. Again?
We were gonna go test that.
Yes, yes. I will give you guys tests back on Monday as well. Cover those.